And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today I'm going to be taking a look at this Amstrad CPC464 computer and its associated CTM 640 colour monitor. Now, I bought this very inexpensively off of eBay. It's clearly been stored in somebody's attic forever and a day, and more importantly, it doesn't work. So let's get into it. Right, so here it is, the CPC464. Now, I sort of didn't get involved with these when they were sort of new or in fashion in the 80s. I was more of a ZX Spectrum, Oric 1, kind of a Commodore 64 bloke. But my mate Rich, say hello Rich.
Hi Rich.
There you go. Well into these, and he spotted this and he said, look, this doesn't work, it's local, it's pick up only. It could be make a useful video, and yeah, so I got it for a good price. I think it is absolutely shockingly filthy. It came with a box of software, but I also notice in here we've got a Master Chess cassette. So yeah, there we go. We've got user port. I take it that's joystick. We've got some sort of I/O there on a 3.5mm jack. Printer port, floppy disk, which has this bit of tape over it. 5V DC monitor. I think there's a speaker under there. And on the end here, we've got a power switch and a volume control. That's not what's going to concern me straight away. What concerns me is the monitor. And we need to do a little bit of preventative maintenance to this before we really get involved with connecting it to the computer. A couple of reasons why. It supplies 5 volts from its internal power supply to power the computer, so we need to make sure that's on the money. And also it uses either an STK or an STM in the power supply, and I don't want to damage that, so I want to do some preventative maintenance to the monitor. It too is filthy. It had come out of somebody's attic. They were emigrating, so yeah, there we are. We have a ticket. Oh, we've got a brightness control on the side there, and I take it that'll be all. Yeah, it is an RGB monitor, so yeah, sort of usual 625 line standard. So you've got a vintage quick shot video commander SVI joystick sticker on the side there, which is rather nice. And as you can see on the back here, it's very filthy. Yeah, what does it say on the rear here? Warning, high voltage, blah 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 blah. DC output 5 volts at 2 amps, made in Korea, CTM 640. Now my understanding is, we've got a vertical hold pot there and a horizontal preset there. This would have originally held 2 little plastic things that you wound the mains lead around. The 2 little plastic things have long since broken off. I don't like the look of that mains plug. We're going to have a look at that. So yeah, let's get a few screwdrivers on the go. First things first, let's deal with this mains plug, because I don't like it. I'm just going to remove it for now, and we shall run it on the unsafe block. Yeah, it's pretty horrible. It does, however, have a 5 amp fuse in it, which is about right for one of these. Oh, perfect example there, look. Why we should never trust somebody else's mains wiring. You see that? It's nicked through the insulation. So yeah, good job we're sacking that off. It's where the cord grip has been put on the internal conductors and not the external conductors, look. And it's eaten its way through, exposing the copper in there. Obviously, if those two come together, there'll be one hell of a bang and we'll blow the fuse. So that's good news. I am going to discard this mains plug because it's horrible. get rid of that. Right, I shall save the 5 amp fuse though, and I'm just going to re-terminate this this bit of lead here, so we lose that bit with a cut in it, because we don't want to be risking that shorting out. Right, that's got that in better shape just for testing, so I can fit a proper plug on it later on. Right, let's have a look what horrors lurk beneath. And while the long and suffering Mrs. Dawes is out at work, I may just get this back in the kitchen sink and give it a good wash and just get rid of all this years of detritus and dust out of the back cover. Two screws there, and I would imagine we've got two underneath as well. Let's pop it on its front. Yeah, look at that. There we are. There we go. And yeah, there's lots of detritus in the bottom of that cabinet. I shall go and get that in the sink in a few minutes. Let's have a look at the chassis itself. It's not too bad, is it? There's a load of dust and horrible in there, but yeah, not too bad at all. I have never known one of these to have a duff tube in it. To be honest, I've only ever worked on one of these previously. So, and that was a long time ago when I had my shop. So one came in for repair, and I don't honestly remember what the fault was. But just to give you some idea, this is the power supply. I think it's an STK, is it? Yeah, STK7308. It's a power supply hybrid, and it contains the power output transistors for the switched mode and all the control. So what I'm just going to do is I'm going to take the mains reservoir capacitor out, and we're going to pop that on the reformer, and I'm going to change these three down here to give this every chance of operating as it should. So yeah, we've also got a lot of that glue that goes conductive and horrible after a period of time, so maybe we should investigate that as well. It's quite clear that nobody's ever been in here before, so I don't actually know if this doesn't work. It was just the eBay description said it didn't work, and when I picked it up off the lady, it was her husband's apparently, and he said it didn't work, so she didn't really have much more information. So let's just take these ties off. Oh, now that's bad news. I just spotted something. That mains fuse is as black can be, which probably means something has gone bang spectacularly. Yeah. Oh dear. Yeah, that mains fuse, that could be bad news. That's probably why it's listed as not working. I will just check its open circuit. I guarantee it is. Yep, that's very open circuit. So that means something's drawn a lot of current, probably in the primary of our power supply here. And if it's that STK, we are now in a world of pain, because I doubt I will ever find another. I might be lucky. Let's just unplug everything. I'm caught up here on this brightness control. How does that come out? Just pulled the knob off there. Does it just slide out? Maybe not. Right, okay. Yes, it does just slide out. How wonderful. Right, what else have we got? Scan coils. just so we can sort of get at it to operate things a little bit. What that is. Right, so something went short perhaps. Let's just measure across the mains fuse to start with. Nothing's measuring short, which is a start. That doesn't mean to say that it's not in bad health. Right. So, no obvious dry joints. Transformer's very well soldered. Obviously, these things were quite reliable back in the day, but here we are 30, 40 years later, and things will have changed quite dramatically. Let me just change soldering iron tips. We'll put a big tip in. We're going to pull that mains reservoir capacitor out, and we're going to put that on the reformer. It is 100 mic at 400 volts. We're going to change these capacitors down there, and we're going to give it the beans and see what happens. So let's just take that mains reservoir out to start with. We may need to put a fresh bit of solder on there to get that to come out. It is, however, glued in with that rotten stuff to the board. I did expect it to just move out, but it's coming. It is coming. I've just damaged a bit of the print. We will be able to repair that though. Don't panic just yet. God, it's stubborn. Yeah, you can see the glue is being really difficult around the bottom of the cap. Oh, I need to get rid of that. There it goes. And we are free. Wonderful. Right, let's put that on the reformer in a moment. I'm just going to have a quick check around. There are a few diodes and things in this power supply we can just look at. So we've got our bridge rectifier down the bottom corner here. So the mains comes in via this filter. That's our degaussing thermistor. And we've got a bridge rectifier here. So we just need to make sure that that's all doing its thing. There are no shorts on there. Which there aren't, so that's good. We've got a diode there. Not short on there. Fine. Another one in there. Ooh. Okay. Yeah, that doesn't bode well, does it? And there's another one there that's reading short. Whoops. Okay, we'll have a look at the schematic in a second. Schematics are available online for this. So we have got D506 is reading short and D507 reading short. I think these are on the output of the power supply. That's okay. And that one's okay. Right. Okay. Let's a look at the schematic, I guess. Okay, so here's a diagram of our CTM 640, and if we just zoom into the power supply here, you can see here's our full bridge rectifier. That feeds our sort of unregulated HT to the top of our chopper transformer here, down into our STK7308. Here are our two diodes that are short circuit. We've got a Zener of some description here, and I think that might be an avalanche device, which is really concerning. And that's D508 that is also short circuit, or is reading short circuit. We will take those out of circuit just to measure them. But yeah, I've got a sneaking suspicion we might have a very damaged power supply here, and the chances of me possibly finding another STK7308 are slim to say the least. But we will give it every chance. But I think we need to pay attention to this circuitry over here, because this could be very bad news in the health of our STK. But anyway, let's get that capacitor on the reformer and see what happens next. Right, well, I've got the mains capacitor reforming on the old Mark 87B Dreadnought capacitor reformer. So that's good. Now we need to start taking apart bits on this chassis. Does that earth lead come out? No, it doesn't. So I just want to take out those two diodes and yeah, work out what we're going to do from there on in. I'm just going to switch the desoldering gun on. Now it was D 507 and 508 we've got reading short. Just going to check 505 etc as well. That one's okay. 507 we know is reading short. 506 is okay. And 508 is short, which is over here. Yeah. Right, let's just wait for that desoldering tool to warm. That is D508. That's D507. So let's just see if these are short circuit. Out of circuit. Yep. And looks like that one has survived. Yep, I think it was just measuring across that diode there. So that is some good news, I suppose. Let's pop that one back in. And let's take those capacitors out. Get them swapped out for new. They've obviously been in a hot location. You can see their jackets are slightly swollen, or shrunk I should say. So let's just take those out while we're there. Get them renewed. I'll do them one at a time. That's 50 volts at 100 mic. Just for interest. See what it actually measures like. Oh dear. Still pretty good actually. So it's 0.26 of an ohm at 102 microfarads. So there's nothing wrong with that. I'm going to change it anyway. Yeah, we might be on a hiding to nothing here if that STK's had it. But if we're not, we might be alright. Give it a nice new one. .220 mic, 35 volts. And that one has gone open circuit. 220 mic, 35 volts. And this one is 1 microfarad at 250. Yep, he's pretty good. 1 microfarad, 2.6 ohms. So it's only that one capacitor we had open. But that's good because now we found something. It does sort of give me encouragement that maybe that's why our diode failed short circuit and it's not the STK. What do I want? 1 mic at 250. That's going to be in my other box, I think. Yeah. Right. Mains capacitor looks to be coming up very well. You see me clicking this switch on the side, that just drops the resistance that's in series with the capacitor. And we are now down to 10k. It's drawing almost no current at all. I'm just going to switch it off, drop it into discharge, wait till that discharges itself, and then actually measure it on the analyzer just to make sure it's okay. That looks like it's come up very well. Right, so all we've got left to do is to find out what kind of diode that is. So yeah, let me pause there and refer back to the service manual. Right, well, according to the schematic, our diode is an RD, 3.6 FB. And cross-referencing that in my ancient Jaeger book, that is an ordinary 3.6 volt, 1 watt Zener. But looking at the schematic, I am now a little bit concerned about Q501. So I'm just going to remove that and check it. So right, we'll just wait for that to warm back up again. I'll get the DCA out in readiness. While we're waiting for that, I can test this mains reservoir capacitor that we've reformed. This should now be in rude health. .62 mic, about an ohm. That's perfectly serviceable, so we can live with that again. Right, gun is now to temperature. That is our Q501, which should be a 2SD1207, which it is. NPN silicon transistor. Yep, so that's survived. So maybe it is just a 3.3 volt Zener, or maybe we get really unlucky. 3.6 volt Zener, let's get that right. Or maybe we're really unlucky and we've done the STK in as well. Let's resolder that transistor in. And see if we've got a 3.6 volt 1 watt Zener. Will I be lucky? This is my drawer of Zener diodes. 3.6 volt 1 watt. Well, that's disappointing. We're going to have to order the right part. Right, well, I just thought I'd have another look at the schematic. And if you take a look, I've put an annotated one up on the screen, probably there. You can see the output transistor inside the STK goes between pins 15, 11 and 10. Now that's pin 10. Between 10 and 11 we have a short, and between any of those and 15 we have a dead short, which means our STK is in fact dead. All is not lost, however, because I think you can still get them. So I've ordered one, and fingers crossed it's not a fake.
4 to 6 days later.
Right, well, it's been a little while because I've been in parts procurement mode. I've got some new 3.6 volt Zener diodes, and at great expense I've gone and found a new STK. Hopefully that's the right bit and it isn't a fake. But before we go and fit that and throw caution to the wind and apply some power, I'm just going to go back over to the schematic and I'm just going to take you through a bit of the procedure. Right, so here's our STK, and as you can remember from last time, this transistor was very, very short circuit in there, and that is our main chopper transistor that chops the DC through the primary of our switch mode transformer here, and regulates and does all that magic. What I'm concerned about is on the output stage here. We have a ferrite bead, BS502. We have our main HT rectifier, which is an RGP30. It then goes up there through presumably a little safety resistor, R521 and L503. Now what I intend to do is to remove probably L503 and hang a 60 watt bulb off the end of R521 back to ground, just to give our power supply some load, just to prove it's all right. Now remember last time I may have mentioned about an avalanche device, and here it is. This is D510, an SR2M, which is an avalanche diode. It's a bit like a Zener. It's designed to fail short when we get to a certain voltage. If we had an overvoltage condition here, this may have failed short circuit in a vain attempt to protect the rest of it. The biggest problem is I won't have one of those. And the other thing I want to look at is this 160 volt 100 microfarad capacitor, which is our sort of HT rail main reservoir capacitor, and I think it would be prudent just to change that out. Nothing is going to bother me on here at the moment. This is our sort of 5 volts output. I'm not worried about that unnecessarily at the moment. It's just this HT rail. I want to make sure it's all right, so I need to make sure D510 is not short circuit, and I want to change this 100 microfarad capacitor as a bit of a matter of course. Right, let's get and look at that. Right, before we go anywhere, I'm just going to blow some of this horrible dust out of here because it's really unpleasant. Right, well that's made the workshop really nasty and dusty now, but there we go, we'll worry about that another day. I'm just having a look on the top camera, see if we can see everything. We can. Our full bridge rectifier is down here. This is our switch mode transformer. So on the output side of this, we should find our RG30 was it? RGP30 rectifier diode, and D510. then it's D510 I'm worried about. That's D511. D509 is here. D510, there it is. It's right down by here. So let's just get a meter on that. Unbelievably, it's still covered in dust. Right. Meter to diode. What I don't want is that to be short circuit. I think it's okay. Let's just get at it from underneath if I can. D510 is there. And the good news is it's not short circuit. That is fabulous news. Right. Okay, so the capacitor I need to be changing are 100 mic, 160 volts, is C515, which is right next to it. So let's pull that out. There it is. That's not, it's not been leaking. It's got a bit of fluff stuck to it, but that's the glue they'd have used to bond it in. I suspect it's fine. Shall we measure it and just have a laugh? It may reform, you never know. It's you on camera there, just about. See what it measures like. It's actually in really good condition. I am tempted to put it back in. Let's see if we've got a replacement first off. Not looking promising. I've got 100 volt rated, not 160. Oh, hang on, all is not lost. I've actually got 120 microfarads at 400 volts, which would be a very suitable replacement. It's a quality brand of part as well. That's a Rubicon part, so that should be very nice indeed. So I'm just going to replace that for that. A little bit fatter, a little bit shorter, but I'm sure we can make that fit. Right. Next job is, I think, to replace our short circuit Zener diode, which was D507. Excellent. I'm going to have a quick look to see if we can find that inductor. L503. 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 Shout if you see it before me. That's down there. So that is our little inductance which I want to lift. And yeah, I'll take our supply straight from the top of our rectifier diode, I think. Right. Next thing then is to swap the STK over. So yeah. That heatsink compound has definitely seen better days. Bit of IPA on there just to get rid of that. Get our new STK. We shall need a bit of thermal compound. Worries me a little bit. The back of the new IC is a little bit tarnished, but it is what it is. A new tube of thermal compound. I'm just going to clean the back of that off a little bit, just to make sure. It is what it is. See some ooze coming around the outside, so that's probably good enough. There we go. I need to do a little bit of leg straightening here, I think. Oh, it's got a little bit crushed in the packet. These always were a finicky blasted thing to want to fit. There it is. That's it. Get some screws back in the bottom of the heatsink to secure it in place. There we go. Let's try and lay that down a little bit more. I'm just going to change my soldering iron tip now to a finer one and just go along there and solder the new IC in place. Just didn't just didn't like the look of the joints on the end of that diode there, so just soldered that as well. Okay, so that's our new STK in. So that's good. Zener diode is in. The next thing to do is to lift L503, which is just here. Let's just see if we can. Let's get a bit of braid, I think, on that. Oh, there it is. That's L503 just evicted temporarily. And I've got trusty old 60 watt dummy load here. I'm just going to put a meter across it and make sure it's still intact. Meter to ohms are about 70 or 80 ohms when they're cold. So that's what we're looking for, and we've got 72 ohms. That's close enough for government work. And I'm just going to pop it straight across our reservoir capacitor, where we took that out, the reservoir capacitor that we replaced earlier. So that's was 100 mic, it's now 120 mic. So that's just going to go straight across there, and that'll give the power supply something to load into. It'll give us a nice visual representation. So hopefully that'll be good. Now the rest of the set won't power up at the moment, not without, because all the power for the set, for the line stage, etc., is derived through L503. So nothing should happen. We might actually get some CRT filaments. I don't know how they're derived. I would doubt it, but I'll just put the base on out of the way. We're going to need a new 2 amp fuse. Can't remember what they are. I shall put them away later. Fuses. Two amp time lag fuse. And yeah, we're ready to go, aren't we? So I'm going to slot the chassis back in. We will need some mains back in there. I think that's all we're going to need though, because nothing else will be working. We will need some power on the end of the mains lead. Now I think I will wind it up on the variac. Now it may cause it to stutter when it starts. We might see it eek, 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 as it comes on with the lamp, but I think it's a little safer method of bringing it up. So a lot of people say, oh, don't put switch modes on variacs. Oh, I've never had a problem. So right, there we go. We're on 0 volts. We are on the front. Fingers crossed. Power is on with the variac and voltage is increasing. That worries me. We were up to sort of 150, 160 volts there, and nothing even made an attempt. What have I forgotten? Mains is plugged in. Ah, hang on, have I just plugged the degauss coils in and not the mains in? That may be the case. No, those are the degauss coils, so that's L502. I would have expected to have seen some activity. Let us just prop that up there and see if we had any charge in our mains reservoir cap off our bridge rectifier. See if we've got anything in there. No, we haven't. Okay, let's just see if we've got continuity through the mains on off switch. Don't forget, we have had an extremely blown fuse, so perhaps it blew the main switch open circuit. Let's just have a quick sanity check there. So meter to continuity. I should have continuity through to there, which I do. I should have continuity through to blue on there. Oh. Which I do. That's disappointing, because my mains fuse failed. I didn't even realise. No, it didn't. It's okay. Right. A little bit disappointing then. Let's pop it back in and just give it the full chameau, shall we? Lamp is there. Right, let's try again, just gently. Nothing whatsoever. Okay. No, we have a fault somewhere. I had an indicator lamp on the unsafe block to show we had mains, but we don't appear to be having much luck there at all. Right, okay, so what else do we have in the way of our circuit? Unplug that plug again, hinge up out the way, make sure I've got nothing lurking in my mains reservoir capacitor to zap me. Oh, I'm nervous now. No, nothing in there at all. So, what I've just noticed, if we got up, and we have got a surge limiting resistor, there is this resistor here. So mains comes in, goes through the fuse, through the rectifier, and feeds this 5.6 ohm resistor here. It's a bit of a surge limiter to knock the edges off before it feeds our reservoir capacitor. And knowing how violently our mains fuse was blown, I wonder if that got taken out with it. I'm just having a look on the diagram to make sure my thesis is correct. Yeah, R601 5.6 ohms. So my meter is to ohms. So across there we should have 5.6 ohms. And we've got 500k. It's blown open. Okay, let's take that out, just check it out of circuit, but it won't be any different. So that's it. It's a fairly large watty wire wound thing, and sure enough, yeah, that's open circuit. You're measuring me there. Yeah, totally open circuit. 5.6 ohms. That might give me a problem in this day and age. Didn't used to years ago. We used to have loads of that sort of thing in stock, but now I'm not so sure. 4.7 I've still got. Look at that. Right. Well, as feared, I don't have a 5.6 ohm. I do have a 4.7 though. And to be quite honest, for this purpose, it's only a surge limiting resistor. It'll be absolutely fine. Right, we're ready again. Fingers crossed, people. Right, we are on the front. On the switch, and we have a lamp lit. That is stunning news. So our power supply is running. That's great news. Now to refit the L503 inductor, which will reconnect our line stage. Just one precaution I have to check with the frame stage before we go any further with that. And yeah, quick another look at the schematic and I'll show you. Okay, so we have an HT rail here when mains is applied, so that's fabulous news. Can't get any further because L503 is currently missing. But what I just want to talk about is the old MUPC 1378H, one of my favourite small screen 90 degree vertical output stages or frame stages. And I just want to draw your attention to C425 here, which is 35 volts 100 mic capacitor. It's the bootstrap capacitor, and if that fails or goes low, it runs a real risk of destroying this IC and me having to put more money into this job. So as a matter of precaution, I'm just going to find C425, take it out and change it. Okie dokie. So we are looking for C425. It's a bit difficult to see just at the moment. Let me just pull this apart for you. Okay, let me make out there is the frame stage on its heatsink. It's a little, almost cross-eyed little IC. And I used to love them. I thought they were a great frame chip when I first saw them. So compact, worked really well. Certainly for small screen sets up to about sort of 20-21 inch, used to see them. But yeah, there we are. I'm just going to remove our lamp because we don't need that anymore. We have proven our power supply out with flying colours. This here is the IC. I'm just going to run along its solder joints anyway, just to make sure they're all right. Yeah, you see that one looks actually grotty now I've touched it with an iron. Right, C425 is there. Yep, 35 volt, 100 mic. It's got a dab of glue on it and I can't actually see which way it came out. Let me just scratch away that glue, which has got the plus sign on it. I think it's towards the outside of the chassis. I will just confirm from the other side. Outside of the chassis positive, yes, smashing. Okay, all we've got to do is refit the inductor, which of course is buried right down there. Okay. It's moment of truth time, I think. Right. Right. It is time for the moment of truth. Yeah, right, let's dim the old workshop lights a bit so we can see if there's anything on the screen and switch on. 5, 4, 3, 2, 1, go. Nothing.
Five minutes later.
Right, power is going on again. Plonk that brightness control in, just in case at some stage I want to turn the brightness up to actually see what's going on. Right, we are all connected. Power coming on. Ah, now I hear life. Ladies and gentlemen, we have tube heaters. Do we have anything on the screen? I don't know as I do. Oh, a flash as we went off. That's a great sign. Let me just bring the screen control up slightly just to see if we can see what we can see. Very quiet. I can't hear it running. But then again, I am as deaf as a snake. Yeah, there we go. We have a raster. Well, that is absolutely fabulous news. It had me worried there for a minute. Clearly, I didn't need to be worried. We've done all diligent checks. We've got a big pot full of bits that we have changed. So, wow, I'm really pleased with that. So the next thing I need to do is make sure I've got 5 volts on this connector here, because that's what powers up the actual microcomputer itself. And if that's awry, we are in trouble, because we need to see 5 volts on there. If we don't have 5 volts on there, and like I said, we are in trouble. Let's just power that up. And I've got 5.194 volts, which is close enough for government work. Excellent news. So the next thing we can do is plug in the microcomputer properly and see if anything's wrong with that. But I'm going to leave that till next week. So thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you next week. And we'll plug it in and play some games or something. Cheers now. Bye.
At Dozie's workshop, he's at love. CRG screens the static shock. Solder burns with steady hands. Phosphor streams across the lines. Circuit boards, electric scenes, bringing life back to old machines. Prepare the view at the sense play. Fix the hue, let the color. Neon lights, they flicker back. Hatch up wires, old tech track. Twist the knobs, make it clear. Vintage vibes is what we hear. Power hums, the screen to life, glowing in the soft blue light. Prepare the view at the sense play. Fix the hue, let the color pixels dance in steady beat. Old as gold, it's hard to beat. CRT with heart of gold. Time of stories to be told. Prepare the view at the sense play. Fix the hue, but the color is.
Because not only is it a let's do this again, because I've muffed it up already. Where are my automatic wire strippers? Are they in here? You'd think they would be. Really?